はい、じゃあ、let's start. Go back to the today's content. Yes, today is talking about what bioengineering is. It means, what is bioengineering? Firstly, it's name of the area and classification and the contents. And then introduce some of the research examples as a basic research, medical application, and engineering application. And then I will also introduce some medical application appliance system, the diagnosis system, and observation instrument, treatment instrument, and the welfare apparatus, and surgical operation robot. And then the history of bioengineering and related academic society. Okay? This is today's contents. Yes, let's start with the first part, the bioengineering. Firstly, these next two materials, seat is mainly for the mechanical engineering based. As I said last week, the mechanical engineering has a basic four major dynamics: the material dynamics, fluid dynamics, heat dynamics, and the mechanical dynamics. So what is the mechanical engineering? Mechanical engineering is based on the dynamics and mathematics and treat many of the various mechanical systems, such as transportation system and the production system, machinery, the processing machinery and the control instrument and the factory automation equipment and so on. But not only is limited in the mechanical engineering field, but also the electronics, as I said, the mechatronics, computer engineering, information science, material physics, chemical process, and so on. The related technology is connected, integrated into the system. So therefore, the mechanical engineering plus the other related technologies, and then some application system has been developed. The chemical machinery, specific environmental machine, and mechatronic systems like robot. Okay. What is the relationship between the mechanical engineering and living creatures or biological body? Firstly, I have to say that it is difficult to treat the biological body. Why? It is pointed out three items. Firstly, the many unknown parts in the living creatures, living things, biological bodies, such as its structure, its component, and the dynamic features, and so on. These basic items, we are unknown. These parts are unknown up to now. Yes, why this structure, composition, dynamic feature is important? Kazuki, why this structure, basic elements is important to treat as a mechanical engineering or treat as an engineering? Some equipment, artificial object is developed for human beings, usage for the human beings. It's okay. But why we need this kind of basic component, basic parts, basic knowledge about living creatures, biological bodies? We want to treat the biological body as engineering. As I said last week, to treat as an engineering, the modeling is our first thing we have to do. Modeling. To make a model. To make a model, its components, some feature must be equalized. Make equations. make a model, some simple model. So therefore, we have to know its structure, its composition, its components, and the components' dynamic features. Yes, for example, the mass damper, spring features of the components, and this component's structure makes some system. So to model this, all of the components and all of the structure must be known before the modeling. So therefore, we need some components mechanical features. But many parts of the biological body is unknown. And second difficulty is the living things is if it is cut out from outside of the body, living body, it becomes die soon. Yes, for example, this is some components, but we can test, yes, pressure test, deformation test, we can do easily. But the living creatures, for example, in the body of the skin, if it is cut out and tested by the pressure test bed or something, this organization will become die soon. So therefore, the original appearance, original condition cannot be, it is difficult to maintain the original appearance, original form to test something of the living body. This is the second important point. And thirdly, the living creatures, living things, living body has some activeness, positive action by itself. ね、なんか reaction, make some reaction by itself. Yes, sometimes it's only some unintended reflection, force or something, but it reacts by itself. Yes, many of the components is only passive reaction, maybe make some passively, but some of them has some activeness. So it is a different feature. This is a typical feature. But bioengineering is important. Why? It is said the three things. One is make clear about the structure, components, and many structures and components and something, and deeply consideration as an engineering viewpoint, make a contribution for the development, medicine, and biology. Yes, engineering viewpoint, engineering analysis, make a contribution to medicine and biology itself. This is one thing. And secondly, is the correct understanding of the human beings body and human health. It is reflected to the medical diagnosis and medical treatment and health sanitation maintaining, and it is help to the health maintenance and body strength increasing. So the totally it is contributed to the society. In findings and some analysis about the living creatures, human bodies, makes the contribution to the human society, human living, daily livings. This is the second point. And then thirdly is the understanding of the biological body, structure and function. Yes, biological body is one of the optimized shape presently, optimal and ideal after long-term shakeout, selection, and the development, improvement. So therefore, some part is optimize the shape, optimize the structure, ideal ideal conditions. So therefore, this understanding about biological body is also contributed to the technical development, engineering research, and technological development. So therefore, first part is medicine biology contribution. Secondly, the society contribution, and thirdly is engineering contribution. Then bioengineering, living creatures engineering viewpoint analysis and development makes contribution in many fields of society. And this is a saying about bioengineering. Many various sayings is there, various similar words there. Biological engineering, medical engineering, biomedical engineering, BME, medical and biological engineering, medical electronics. It is focusing on the electrical signal processing, and biomechanical engineering is also set, mechanical based. And then the bionics, biomechanics, biomechatronics, biorobotics, the similar words. But bionics is mainly related to the corresponding to the cybernetics. Cybernetics is some of the artificial intelligence or some of the artificial body. And then the bionics is bio living creature, and some of them is mimetic and following, and then the understanding, and then it is used for the technical applications. Biomechanics is one of the dynamics. This kind of mechanics is some of the mechanical features, understanding and application. So therefore, this is the dynamics-oriented thinking. Biomechatronics, biorobotics is application-oriented. Some of the integration of mechatronics and bioengineering, and some of them is mechatronics, robotics and bioengineering integration. Not so much meaning for these various related various words. But why we select these words? Because of the which part we are focusing on, which application we are focusing on. Yes, that's target application or target research field or something. For example, this is medical electronics is focusing on the biological signal processing, and the medical engineering is the medical equipment or medical treatment based something, and the biological engineering is the biological body itself maybe, and so on. Then, what is classification and contents? Classification, for example, the target-based, approach-based, viewpoint-based the classification. One is element, component understanding. Second is function clarification. And thirdly is system maintenance. だからsmall element, some organization and system という感じなんです。エレメントの、だからエレメントはコンポーネントはマテリアルレベル、ティッシュレベル、オーガンレベルって言って、だからマテリアルレベル、ティッシュレベル、オーガンレベル、それからこっちはファンクション、システムファンクション、なんかシステムファンクションでもこのオーガンファンクションでもファンクションレベル。ファンクションっていうのはファンクション。はいさん、ファンクション、Whatファンクション。 for body. Anything okay. What is function? What do you estimate the word function?
Like a child when he starts walking, so his legs start to function.
function ね。何かな。なんか mainly I think the function isなんか input output causality relationship. What is the input and what is the reaction is this kind of thing. This kind of なんか input output relationship is called function mainly. I feel. So therefore the なんか mechanism function the mechanism から from mechanism function is we can extract some function from its mechanism maybe. Thirdly is system level. So therefore the some system it used for example the rehabilitation engineering or health welfare science and sports science and so on. This knowledge is used for the many fields of society. So this is one classification, yes, element level, the function level, and the system level. Thirdly is the next is the content of the bioengineering. Bioengineering activity is research and development is divided into, for example, the basic research, medical application, engineering application. Yes, basically we want to make clear its structure and function, and it will be the clarified structure and function will be used for the medicine and biology, and this is used for the engineering itself. So for designing the artificial object, manufacturing of the artificial object, and the new application development. So どんどんいくと、で、I will show these この these three contents の I will show more detailed example. Firstly, about the basic research. Basic research example. Basic research study example of the basic research is one is a component material no or the structure of the structure configuration, dynamic behavior of the component material and construct. For example, this is a molecule level, cell level, tissue level, organ level. So therefore, many various kinds of levels, the shape and the property and the deformation, strength, and so on is clarified, especially in its dynamic behavior, because we want to model it to simulate it. Secondly is inside-outside living bodies flow, focusing on the flow. Flow is not only the area flow, so the breathing, but also blood circulation, for example. Yes, of course, respiratory, yes, breathing apparatus, and also the gastrointestinal materials, and also urine, and as I said last week, joint fluid also to make the friction force reduced. So this is in vivo. In vivo means internal body flow, inside body flow, and also the outside body, like the fishes swimming, and the bird flying, insect flying, or aircraft flying. rocket flying. Outside the body's flow is also the one important point to make clear. And thirdly is exchange metabolism of heat, oxygen, material, and information. Yes, thermal therapy, thermal property or heat transfer and the oxygen material exchange between inside the cell, outside cell, or inside organ, outside organ, inside the one living creatures and inside and outside. This kind of exchange transformation is also discussed and investigated. And finally, physical dynamics is also analyzed. For example, the joint dynamics feature, the spinal cord feature, or working posture, gait motion, and impact against the body reaction. It is very important for the car body designing, for the driver safety. Some simulation, including the driver physical body's simulation, is also included. And heart eyeball stress analysis, because the heart is the continuously moving pumping action. Breathing action is also in the lung. And auditory organ analysis, the inside body sound propagation analysis, and so on. This is this is you are familiar about physics, dynamics. So therefore, we can estimate. The firstly is material itself, material engineering, related to the material engineering. Secondly is flow, so therefore the hydrodynamics. And then this is heat engineering, thermal engineering. And this is mechanical dynamics engineering. Yes, four major engineering is completely related to the basic research of the living creatures. You may understand. And the second part is contribution to the medicine and biology. Medicine, medical application. Yes, diagnosis equipment, measurement instrument will be developed. Blood pressure, blood flow measurement instrument, and aorta, arteriosclerosis, この blood vessels harden estimation, measurement, and heat function measurement device, and joint function testing equipment, and so on. This kind of diagnosis analysis and measurement instrument is developed. And also the medical treatment itself is also developed, like the wounded part treatment method, the assisted circulation, because when the part is make some injury, suffer from some injury, some assisted device is the additional circulation is added or something. And also the artificial suspiration method or rehabilitation technology is developed based on the understanding of the physical body, human body. And artificial organ, many artificial organ is now developing now. Artificial skin, artificial bone, artificial heart, artificial cardiac valve, and artificial blood vessel, artificial lung, artificial tendon and ligament, and also artificial joint replacement surgical operation is held for the elderly people in many cases. And rehabilitation engineering and prosthetic engineering, they are like the prosthetic limb, artificial hand, artificial leg, and the assistance robot, the nursing care robot, electric wheelchair, some electrical care bed, gait gate training, assisting equipment, and so on. And also the sports equipment and the training method will be also examined. Yes, okay. Thirdly, the feedback to the engineering. この部分は maybe you may understand. Maybe biomimetics, the similar じゃない。Following to the biological creatures, feature or systems, following this, and it will be applied to the engineering. The living creature's movement structure is imitated, and its function is created artificially. So therefore, by using the biomimetics technology, it makes the robot more flexible, more versatile. Not only robot, but also some functional materials, intelligent structure will make more flexible or versatile or durable or something. More use. Using the engineering knowledge, biological knowledge. Yes, for example, I introduce 3 examples. One is a honeycomb body, honeycomb structure. Honeycomb structure looks like this. Honeycomb body ね。ヘキサゴンね。ペンタ、ヘキサ、ヘプタ、ヘキサゴン。Yes, as I showed in this video, さっきこれを見せましたよね。Structure paper honeycombボディの、ボードっていうのは IKEA のボードを 見ましたね、さっき。ちょっともっと違うやつを見ますか。例えばこれか。
Cell Pack has manufactured environmentally friendly packaging for the fixing and shock absorption of products during transport. Our packaging is paper-based. This means natural products, new paper, craft liner from wood and or recycled paper, and water-based glue. Our packaging is therefore 100% recyclable and biodegradable. The core in our honeycomb packaging has a unique cell structure, hence the name honeycomb. This natural construction of cell-shaped air-filled spaces makes the packaging very strong and very light at the same time. Often, our packaging replaces EPS, expanded polystyrene, which is an oil-based product that does not have the same environmentally friendly properties as paper-based packaging. We supply a wide range of European customers who use the packaging for shock absorption and fixing of all kinds of different products, such as pumps, valves, furniture, electronics, glass, bottles, and other fragile products which are vulnerable to impact and transport damages. In cooperation with our customers, we develop optimal packaging solutions using paper honeycomb as the basic material. We manufacture the honeycomb panels in a number of different variants, sizes, and qualities. One of the advantages of using our paper-based honeycomb solutions is the fact that they are recyclable, biodegradable, and not least, compressible, which is a further advantage. Disposal is hence easy and low cost.
ということで、このhoneycomb structure is very useful to other. Yes, in this case, is based on the paper material. And it is used for the lightweight, shock-absorbing component packaging material. Yes, so this looks like this. And the next is a vortex generator. You know the vortex generator is this holes, the end of the holes wing. This kind of material, this kind of structure is there in the end of the owl's feather, Yes, vortex generator is inspired by this. The tiny protrusion group is the make the flow smoothly, make the air flow smoothly. You may know fine the aircraft can flow. aircraft. さてこれウィングだけど、ウィングでこうなんかフロー、エアフローがこう来るんだけど、fine, this wing can flow. はいさ、fine. Aerodynamics. What is that? まあ、you can say simply, fine, this wing floating. F.
It has force, drag force.
Okay. For force, why this force will be produced?
Pressure and
Yes, yes, pressure. このプレッシャーなんだけど、エアプレッシャーなんだけど、ね、こっちの方が highly move, and this is slowly, and also this is high pressure, and this is low pressure. So therefore, the pressure force, the total of the pressure force, this wing is floating. Yes, it's okay. But how about the flow of this air flow? まあこっちはスムーズリーね。これ it along to this surface, maybe it flows. But how about this part? まあ slow movement. If it is slow flow, it can move like this. Slow flowing, it moves like this. But more higher speed, if it has a higher speed, this is not only along to this wing surface, but it is more fastly it moves. So therefore, there is no contacting force, boundary layer is there. So what happened about this area? It makes more reverse flow is making, or some making disturbed flow is also generated after the wing. So therefore, it makes this floating force is unstable. So what is vortex generator? ちょっとどっかこれでもいいや。What is the vortex generator? You can understand by watching this video.
So I recently had access to a 3D printer, and it's really cool how many 3D parts and models are out there free for you to print into real life. I am an instrument-rated commercial pilot, currently training to be a flight instructor, and so I've come across vortex generators before as used on aircraft wings. I logged a dozen hours in a paper Super Cub with VGs installed on its wings. But what do these things actually do? Let's take a minute to see how moving air reacts with a solid object. Because air has friction or viscosity, it can act a little bit sticky. Not nearly as much as honey or oil, but it's there. And if you have a free stream of air moving along a solid surface, the air next to that surface gets slowed down by it, and that friction propagates upward. This area of slowed down air is known as the boundary layer, and is why you can never quite blow all the dust off of things. As air flows around a curved surface, it would like to follow that surface all the way around. If air did not have any friction, it would flow around this ball symmetrically. High pressure at the front and back, low pressure at the top and bottom. And there would be no drag because the pressures are symmetrical and there is no friction. However, what you actually get in real life is a wake. This right here is particularly interesting because the air is going from an area of low pressure to an area of greater pressure. And that's kind of weird because things always want to go from a higher pressure to a lower pressure. But the air has enough speed and momentum to push through it. With no friction, the air would conserve all of its energy from accelerating around the ball, and have just enough to leave the other side at the same speed that it started at. But since it has been slowed down by friction, the boundary layer doesn't have enough energy to push through.
It slows down to a halt and then actually starts to go the other way at the surface. And right there, that is when the airflow separates. And that area of reverse flow is called separation bubble, where air is recirculating and it has a lower pressure. And the difference in pressure between the high ram air pressure in front and the low pressure separation bubble in back causes a force known as pressure drag. Another way to look at it is that the air has mass, it has weight and momentum, and at the front of the object there is a point called the stagnation point, where the air is compressed and the velocity is brought to zero. It's like we are constantly grabbing air and pushing it with us. Similarly, the wake in the back is a low-pressure separation bubble where we are grabbing a bunch of air and pulling it with us. We are giving it some of our energy and then letting it go, and then grabbing some more. I noticed that the raindrops on my car's rear windshield wouldn't get blown off when I would go down the freeway, indicating that the air has separated and was not attached. So I thought it'd be a cool idea to try and 3D print some vortex generators and then put them on my car's rear windshield and see if they would help delay airflow separation. Here is my test.
Without vortex generator は
As you can see, without the VGs, the telltales are swirling all over the place from the circulating currents in the separation bubble behind my windshield. With the VGs installed above the middle section of the window, we see a huge improvement. This theoretically reduces pressure drag, however it does increase lift at the rear wheels, which reduces traction. But how do these vortex generators work? When air is being redirected around an object like a piece of plywood or maybe an airplane wing, and lift is being generated, there is a lower pressure on top and a higher pressure on bottom. And this higher pressure can escape to the low pressure around the wingtip. This causes all the high pressure air to move outward and all the low pressure air to move inward. These sheets of air are called vortex sheets, and at the tip they roll up into a vortex. And so a vortex generator is just a little wingtip pointed up through the boundary layer, mixing the layers. The air on the high pressure side is moving upward and the low pressure side moving downward, and at the tip it rolls up into a vortex, mixing the air from above the boundary layer with air inside the boundary layer and preventing it from staying close to the surface for too long. I also briefly tried putting these on the outer wings of my latest scratch-built RC plane, and I could definitely tell a difference. It just felt safer and more controllable at low speeds. The inner wing would easily stall, but the outer wing would maintain control. It's pretty interesting how you can actually hear the wake of the wing. At high speeds and low angles of attack, the air is smooth, but at low speeds and high angles of attack, the wing's turbulent wake is hitting the tail surfaces and the camera.
まあ、とかいうように、だから to make it stable, even in the slower speed, this vortex generator is very important. And it is found out based on this All's wing, All's feather. だから lower part to the upper part. This structure is very important. Found it out. と、それが2つ目。This is the second example. This is also used in the Shinkansen's pantograph to capture the electric energy. This is a line, electric line, and by using this slipping by this part, the electric energy is given to this car body. And here is the vortex generator is put on this part to make the noise reduced, and the vortex generator is reduce wind noise. And the third part is seeing wear, seated swinging error. This is following the shark's skin, surface skin, or penguin's skin, penguin's skin, or this water shedding property is followed by this penguin's skin. And ちょっとどれかな、短いです。これか。
I think sharks are really fascinating animals. They are kind of maximum in the evolution system. So they are almost perfect animals. And in this respect, we can shark skin is not smooth as one would expect, but is very rough, and this roughness is then faster in the water. Why this roughness is improving swimming? There is a reason, and the reason can be explained in mathematical terms. Okay, when we have a shark in the water, in this region around the shark, there is another dynamics related to what we call the water viscosity. So, the water viscosity is responsible of resistance of the water to the swimming. This occurs like when you take cards and you throw these cards in this way. So the fluid, each card is a kind of layer of fluid slipping one over the other. And this is the action of viscosity. This action is creating some vortexes on the surface of the shark. And these vortexes are dissipating energy. Now, if the surface is not flat, but is rough, like we have on shark skin, this roughness is breaking these vortexes, is reducing the occurrence of these vortexes thanks to water trapped in these valleys of the rivulets. The roughness of the shark skin, the presence of these rivulets, makes the shark faster. In the Olympic Games of 2004, a couple of companies tried to reproduce this effect on the swimsuits of Olympic swimmers. And I was working with one of those companies in Europe, and we reproduced mathematically the effect in order to quantify the real advantage and try to identify an optimal shape and an optimal sizing of these rivulets. We found an advantage, a reduction of drag around 14%. After Olympic Games of 2008, the swimsuits were banned because they are this kind of technological help is supposed to be, or is considered to be, a technological doping. One of the most important things of mathematics is that you can do experience in one field like shark skins and then use this experience in a completely different fields like motorcycles or blood dynamics. We can use
まあそういう感じで、so therefore you この this video is the Polytechnics di Milan だからイタリアン University イタリアン Technological Schools simulation result. Okay, so you may understand that as he said, the modeling and simulation is very important. And once it is modeled, it will be applied not only the swimming suits but also the automobile designing or something. Yes, so therefore these three examples I have introduced, you may understand. And then yes, this is biomimetics. Based on the biological body's knowledge, you may apply to the engineering applications. And secondly, it is also the optimal designing technique because, as I said previously, one of the living creatures is optimized after some generations. So therefore, following these shape or function, the shape or construction method, development deformation method, we can learn from the living creatures and it can be applied. Yes. And I will introduce some of the examples of the medical equipment systems. Firstly is a diagnosis system. Two major diagnosis systems presently is one is X-ray computed tomography, X-ray CT equipment. The other is MRI, magnetic resonance imaging. CT looks like this, and MRI is here. So you can see some history or some mechanism of the CT and both CT and MRI. If you can, you should watch these videos afterwards. これはまあいいや、ちょっとこれスケールするんだけど、 PDF ファイルが You may have the PDF file ね、on the コースナビで You may have the PDF ファイル、ちょっと待ってね、で例えば今言ったボルスペックスジェネーターのやつもあるじゃん。で、例えばこれでここの動画を You may want to know this movie, You may want to find this movie, You should copy this word to and using the search engine, for example like Google, you may find some of the Ctrl V でリターンして2でこれ動画とかやれば You may find just this one or some similar movie on the net. For example, the YouTube video you can see, you can find, and then you can access like this. So please do this if you want to watch some videos I introduced on this file. Okay. Yes, じゃあちょっとこれをするとしまいで、so go back to the PowerPoint like this. So in this case, it's also you should, if you want to find some video like this, you should copy these words and paste it to the search engine, and you can find some you can find some videos similar to this. Okay. はい、です。まあいいや、だからこれちょっと時間がないので、I have no much time, so skip these examples. And the second example is observation instrument. Yes, the medical equipment manufacturers is firstly started with the observation instrument because some treatment or operation equipment, it is difficult to make, and it is make some dangerous to the patient. So therefore, the firstly developed as firstly observation instrument development. ね、だから、for example, this is endoscope. You may know the endoscope by watching inside of the gastronodes, and also the ultrasonic diagnosis equipment looks like this. If you marry and if you have some wife who is expecting, by using this kind of ultrasonic equipment, your baby you can watch maybe. And also presently the capsule endoscope is also developed. Capsule type endoscope is also developed, and it is automatically capture the images inside of the body. And then afterwards, or this image is the wireless transferred into the outside body computer system, and then it is analyzed, and then it is diagnosed. For example, this is a Olympus capsule endoscope.
For more than half a century, Olympus has been a leader in the field of medical endoscopy. Since releasing our first generation endocapsule system, we've been refining our capsule endoscopy design and technology. And now we're introducing the next generation. With the Olympus Endocapsule 10 system, we're ushering in a new era in capsule endoscopy. The Endocapsule 10 system offers a variety of advanced features, including innovatively enhanced components that will facilitate more precise examinations. Whether you're new to capsule endoscopy or whether you're already relying on it to help improve clinical efficiency, we think you'll find that the new Endocapsule 10 system will become an indispensable tool for your gastrointestinal diagnostic work. The endocapsule 10 system excels in 3 critical areas: visualization, efficiency, and usability. Olympus lens technology coupled with extreme high-resolution sensors provides clear and detailed images. The capsule not only captures a 160-degree field of view, it also provides optimal lighting, clarity, and depth of field for each of the thousands of images it captures. The images captured by the endocapsule 10 system feature superior brilliance and clarity when compared to the previous model. The endocapsule 10 system also introduces 3D track. This feature makes it possible to track the capsule's location throughout the small intestine.
The inside body, maybe you may know, it's dark. So therefore the lightning is necessary to capture the image. So lightning makes to consume the much energy. So therefore the battery technology is a very key point of this kind of capsule endoscopy. Okay. And also, of course, the camera's resolution is high quality resolution is necessary to make the diagnosis more exactly and detailed. So therefore the camera technology, imaging technology is also important. But energy source, lighting is one important issue to realize this kind of capsularized endoscope.
This has many useful applications. For example, using the 3D track, you can estimate the progress of the capsule endoscope, which will allow you to make better decisions on whether to follow up using small intestinal endoscopy by the upper or lower approach. And the enhanced 12-hour operation of the endocapsule 10 system ensures maximum completion rates for observation of the small intestine. Thanks to our new endocapsule software 10, physicians can spend less time reviewing images or writing reports and more time with their patients. The software offers a new algorithm that automatically detects bubbles and debris and selects only frames that provide significant visual information, which helps save the physician time while reviewing images.
もちろんだから、of course, image processing is necessary to this kind because the many of them is based on some images. He has the doctors has to find some cancer material, cancer portion or something by watching these videos. So therefore, the precise image is necessary and some make clear, clarifying and some emphasizing technology about image processing, and also the recently AI technology is used. So watching many images, and then the AI system find out which part is the early stage of the cancer or something is the estimated more and more exactly by watching many images. This is presently the doctor's skill by watching the images, and then the diagnosis something is made to the images. But recently and gradually AI technology is used to the image processing and image recognition and image discrimination. Of which part is healthy and which part is injured or expecting some becomes a cancer sufferer or something. Okay. They skip to this video, and this is image processing. And also the example of the equipment is one of the medical applications, the welfare apparatus. So the intelligent hand, intelligent leg. This is a knee joint, or some socket designing, because this interface is very important for the users, and it is depending on the individuals. So the measure the shape of the remaining body completely, and then the appropriate socket must be designed, easy to put and easy to take off. and then the no pain between the interfaces. So the CAD/CAM technology or NC working technology is also used. And the wheelchair, this wheelchair can climb the stairs and standing up on that, and to make the user's viewpoint is make higher to up to the similar to the normal human beings. And then this is a modularized wheelchair, electric wheelchair. So this is the motor to drive. This wheel is equipped on this wheel base, and some battery or controller is attached to the battery, and the controller is attached to the normal wheelchair. Yes, and also the surgical robot. You may know that Zeus. Zeus is Zeus Da Vinci system is the most familiar, most famous, most familiar surgical robotic system. By using this console, the doctor is operating two hands to manipulate a hand, master arm, and then the two arm is operated by this doctor, and the doctor watching the three-dimensional high-resolution images, stereo images, and this third arm is holding the camera inside of the body, inside of the patient body. So the micromechanism, master slave arm control, image presentation technology is used. So this is the end part of this this robotic hand, the wire-driven hand. This. Alright, let's see. The next 6 pages is explaining about the bioengineering's history. It is go back to the ancient Greece period. Philosopher Pythagoras, maybe you know the Pythagoras. Pythagoras' theorem. Kazuki, what is Pythagoras の定理? Pythagoras theorem って何? なんだっけ? ピタゴラスの定理なんだっけ? ピタゴラスの定理って三角形だよね。直角三角形。パーペンディキュラートライアングルのこの A、B、C の A 事乗プラス B 事乗は C 事乗だよというのをメイクなんか証明した。Hey, you can do this. You can do this. The improvement. How to show this equation is true. Many ways there. A 事乗 plus B 事乗は C 事乗。Many ways there. So you should check afterwards. This is simple mathematics. And he is not only this mathematics giant, but also he is a medical fields also he is contributed, because brain is the most sophisticated activity, central organ, he firstly said. And then the next is Hippocrates. Hippocrates is also the ancient Greece's scientific medical doctor, and he is called father of medicine. Father of medicine. Pythagoras じゃなくて Hippocrates. Because the Hippocrates is mentioned oath of Hippocrates. This is the morality and objectivity about the thought, ideas and consciousness for the medical medical peoples, medicians. So, for example, you may show that. So, this is the several item is listed up for the medicines, for the morality and objectivity. So this is also set for the graduation ceremony, commencement ceremony of the medical schools. All the graduate student is saying about this oath. So it looks like this.
I solemnly pledge to consecrate my life to the service of humanity.
I will give my teachers the respect and gratitude that is their due.
I will practice my profession with conscience and dignity.
The health of my patient will be my first consideration.
I will respect the secrets that are confided in me, even after the patient has died. I will maintain by all the means in my power
The honor and the noble traditions of the medical profession. My colleagues will be my sisters and my brothers.
I will not permit considerations of age, disease, or disability.
Creed, ethnic origin, gender, nationality, social standing, or any other factor
To intervene between my duty
and my patient.
This kind of saying is gathered and saying at the commencement ceremony of graduate school, many graduate schools in, for example, in the United States and in Europe. Also present. And show これね、まあいいや。で、アリストテレスはなんかバイオロジカルモーションのオブザベーションディスクリプション like the development of the chicken or some animal dissertation is made. Yes, here he is also the physiologist. And you may know the Leonardo da Vinci, and he has remaining many sketches about the human body. So the dead person's body is observed, and then he has remaining some sketches about this. So therefore, this is also the very famous chart. The built with man. This is very famous. And he is familiar is also some aerodynamics or something. So the wings and aircraft and the propeller machines is also he has estimated. And Galileo Galilei is maybe you may partially know about astronomy, but he is also contributed by the medical field. For example, this is a long bone. The long bone is the isotometric この例えば pendulum's movement is also that he has found it out, and it is used for the heart beating. This human pulse rate, the measurement, this pendulum movement is used. And also the example of the human body long bone, analogy is not good, is described by this Galileo Galilei. アナロジーってだからさ、スモールボーン、スモールボーンってこうあるよね、スモールボーン。で、なんか、アナロジカリー、same ratio development is looks like this. Same ratio development. But actually it's not true. Actually it's more slim bone is developed. The small bone and not actually the isometric development. But the more slimmed, simple bone is developed. Why it is? ファイさん、ファイ。これ、this is, この not, yes. これ、例えば、ベイビーね。ベイビーのボーン。で、アダルトボーン。ベイビーボーン and adult bone is not asymmetric. Why it is? え？何？ハモティボン。あ、オプティマル。だから、how optimal?
Light and most stronger.
ああ、right ね。そう。If it is the same thickness, the weight will become larger because the size is L だけど weight は L の3乗だよね。3 power, third power increasing. So therefore it become more slim to make the strength weight relationship. ね、だからbecome large, so the strength become large, but weight become more larger. It is not good. So therefore the asymmetrical scaling, analogical development is not good. So Galileo Galilei first said about this. はい。というわけで、あとはウィリアム・ハーベイという人がそのハート、ブラッドサーキュレーションを firstly he found. And Descartes, you may know the Descartes is a physiologist. 例えばこれだ、なんだっけ、10ペンス、どうして10水。だから I think, therefore I am, you may know this word. But he is also the thinking the human is some part of the mechanical body and soul. So the body can be replaced as mechanically, he said. そうだ。メカニズムとなんかソウルは can be separated, he said. It is a mechanical view of nature. And then 例えばこれはボレッリっていう人はこのなんていうかマッスルボーンストラクチャージョイントリンクメカニズム he has developed and analyzed ボイルシャルルのボイルっていう人はこれはボイルの法則ってボイルズロー is he found but he also this is developed because of the some このvacuum chambers test he has done. For example, the oxygen is very important for living. He is discussed about this. So by using this pump and chamber, this Boyle's law is he found, he developed. And Robert Hooke is a spring constant, is he found. Hooke's law, but he also used this microscope and then find this chamber from the cork of the wine cork. Small chamber. It is called cell. He said this small chamber cell. So he is very important for the medical engineering. And also Young, トーマス・ヤングっていう人は、ヤングってこのストレイン・レイシオ、Young's law, some mechanical engineer knows about このエラスティックモジュールですね。エラスティックコエフィシェント、Young. But he is also found the retina's structure, eyeball retina's structure, oculus eye research work is also there. So some color detection is made by cell. The three main color is visualized by using these three main cells. Red, green, blue. He has estimated. Young-Helmholtz theory. これはジン・ルイス・マリー・ポワズイユ、ハーゲン・ポワズイユズ・ロー。 some of you knows about the fluid dynamics. The inside the tube, this viscosity flow is equalized by using the Hagen-Poiseuille's law. で、あとはなんだこれ、ヘルムホルツだ。ヘルムホルツ is a Berlin University's professor ね。He is also doing the eyeball research works. So the young Helmholtz's theory is established by him, and also the hearing eye organization's work is also there. The cochlea is the discrimination of the resonance is also he found. And also others about the nerve condition, velocity, or the sunlight radiation energy analysis, and also the energy conservation laws is also he has mathematical, so equalized about the energy conservation law. Law itself is other person about 50 years ago has found, but the surely equalized is by the Helmholtz. これとおしまいか。So therefore, maybe you may know some giant of some other field, especially in the mechanical engineering field. But they are also some of the application is made for the human beings. And then he found many equations, many theories, many laws by doing some mechanical engineering works and applied based on the biological observation, biological measurement or something. And this is a related to engineering society. This is JASME is a Japan Society of Mechanical Engineers, and also in Japan, SAIS is a Society of Measurement and Instrument の Society です。あと SOBIUM っていうのは Society of Biomechanism。And in Japan, the JSMBE は Japan Society of Medical and Biological Engineering。And American Society だったら ASME とか American Society of Mechanical Engineer の Bioengineering Division とか IEEE の、Institute of Engineering and Electric Engineers の Medicine and Biology Society とかもありますということで、これトランザクションは Some journal papers is published on this journal transaction. For example, the transaction ASME Journal of Biomechanical Engineering and IEEE の Engineering in Medicine and Biology Society Magazine とか Transaction of Biomechanical Engineering とか Transaction of Neural System and Rehabilitation Engineering とか You may access through the Waseda from inside Waseda University freely. You can read many journal papers from inside Waseda freely. Yes, so that's all for today's work, and I introduce this. From tomorrow, the one exhibition is held at the Kokura, West Japan General Exhibition Center Annex in Kokura. It is located here, and it is held from 10 o'clock to the 5 p.m. It is a new annual exhibition about the regional environment and energy, advanced technology, and political venture companies, MESSE and KSPS. This Science and Research Park's exhibition and KVIC, Kyushu Venture Innovation Fair, and keynote speech and some seminar is held, but of course they are all in Japanese. So if you can understand Japanese, you should attend there, and also even only if it is about only exhibition, many companies or some organizations have some booths to exhibit, So therefore, if you want, I will give it to you. And if you have a chance to, if you have a room to visit Kokura, you should go there. Okay? Because if you visit there and if you give me some report about this visiting and what you have watched, what you have learned and something, I will give some additional score to this usual scores.